I'm Patrick Bailey with IQlist.com. Today is, May 19th, 2018, and this is a Manipulative Monday. Okay, this is a follow-up to our last Manipulative Monday, and in that video, the challenge was to put numbers so we could actually kind of physically hold numbers. We could do some math problems and set them out before our kids for teaching. And that worked pretty well. We did it in Tinkercad. You can kind of see some of the designs we did here. And there were some cool things we found out, like you could actually put some Unicode in here. And it worked pretty well. I liked the results. One of the drawbacks was your limitation on fonts. You only had a couple of fonts you could choose in Tinkercad, which is fine, and they worked pretty well. Also, some of the Unicode characters didn't quite work, but a lot of them did work, so overall, pretty successful. But Osloy posted a message here, basically saying, why don't you try OpenScad, which does support Unicode and can do the same thing. And so I guess he did a few tests in there. And so it seemed like a really good idea to me for doing this. So I'm going to go try to remake what we did in Tinkercad in OpenScad. Now, before I go down this road, I think OpenScad is a really good tool to use for this. But I do still advocate using Tinkercad for this. Not necessarily for the results, but the fact that for the end results, because you can do Tinkercad with your kids as you're teaching them the numbers, and so they can be part of the process of making the numbers. With OpenScad, it's a little harder to make them part of the process, especially if they're younger, because OpenScad is a little more difficult to grasp and work with. So pick your poison. But with that, let's get going on OpenScad. Now, if you're not familiar with what OpenScad is, I'll just start off on a very small primer. So, let me go, should have opened up another window here, huh? Well, let me go back to OpenScad. What OpenScad is, it's a way to write code that defines a design, a 3D design. So you can write some code. If you're a coder, it's really neat. You can define all what you want, and you can save it like a simple file, and you can push a button and render the code. Really, really neat. But with that, I'll go through a little small primer, and then I'll kind of just go and get the job done. So if you're unfamiliar with OpenScad, you can actually go to openscad.org, and there should be a download. So go to the downloads. You can download it for Windows. You can download it for Mac. I'm pretty sure you can download it for Linux. No, I am sure you can download it for Linux. So you can download it and open it up and start working. But let me go back to the cheat sheet, because there's a cheat sheet here, which is probably a good site to reference when you're starting to do this. So let me go open up here one of the OpenScad windows I have. So here's OpenScad. And what you can do is over here you can code. And on the right side you can see what your render is. And then when you're done, you can save it as an STL file. So we'll do something really simple here. I'll go over here, and for 3D shapes, there's a sphere. And you can click on any one of these and kind of go get some more information on how the sphere works. Let's just do a simple one. So here I can say, a sphere, and I can, do a bracket there and put a number in there and a semicolon to end the piece of code. And that basically says, make a sphere with a radius of 5. And then from here, I can push this button here, which is the render button. I click on that, and I have a sphere with a radius of 5. And usually that 5, I think, it's kind of unitless, but when you start sending it as an STL file, it ends up kind of becoming millimeters. So if I go here and do 25 millimeters, that's roughly about an inch. And if I save that as an STL file, and I'll do that real quickly here on my desktop, and I'll just call this sphere. And if I open up Prusa control, and then if I got too many unorganized windows here, let me just click on that, go to my desktop, and there is my sphere. And if I take that, which I've just saved, drop it in there, we'll see there's a sphere, and that's, about a 1-inch sphere. It's not going to print very well, but you can see we can make shapes. Just wanted to show you that. So there's spheres, there's cubes, you can translate, you can subtract and do unions. There's all kinds of really cool things you can do with this program. In fact, if you go on Prusa website, they're one of the 3D printer. If you go to the Prusa website, all the 3D printed parts of the Prusa controller are written in OpenScad. So you can actually download those files and render them on here, They also provide the STL files, but it's interesting to know that people like Prusa are using OpenSCAD for their designs. So with that, there's just a very small, simple intro. Let's get going and see if I can replicate what I did before. Okay, now let's try to replicate this. So the first thing I want to replicate is the little, is the platter. And so the platter has rounded corners. Now, in this code, there's no simple way to just say, hey, make me a square with rounded corners. They don't have that. They have cubes and they have cylinders. But I can combine cubes and cylinders to get that effect. So let me go over here and start with that. So let me wipe out this sphere. And what I want to do is I want to create a cube. So I'll start doing some variables here because I can actually, the nice thing is I can start doing some variables. And the first thing you probably want to do if you're new to this, there's a star fn equals, and you assign a number. That's kind of how many faces it's going to make. That's how detailed it will make it. And so when you're first testing things out, you probably want to pump that number down lower, like a 12. And so I'll show you what that really means. So if I do fn 12 and I render it, let me make that big again. You'll see the sphere became more blocky, but it renders quicker. If I pump this up to 40, it becomes more smooth. So when you're testing things out, you probably want to leave that number low, which will make it kind of chunky and blocky. But then when you're done, bump the number out and then get your final render done. So I'll put it at 12 just for now. So what I want to do, I come over here to the cheat sheet. And some of the 3D shapes they have spheres, they have cubes, and they have cylinders. So I'm going to use a cube. And here if I look at this, I can have a cube with a width, depth, and height. And that's kind of what I want. So before, I think we were doing ours. I can go click on it. I think these were, 40 millimeters by 40 millimeters. So I'm going to stick with that. So I come over here, I could have a cube. Oh, come on, type. If I could do a cube. Now, if I gave it just one number, 40, it's going to be length, width, and height of 40. And so that'll actually make a cube, which is not what I want. What I really want is a little platter like that, and it should be X, Y, and Z. So I could do 40, 40, and then a height of, before I think I did 2 millimeters. So I'll do 2 again. And there we go. I've got a little simple platter over here. But I want to round those edges. So the only real way to do that is I need to put cylinders there. So what I'm going to do is rather than do a cube that's 40, 40, 20, I'm going to make 2 cubes that are going to overlay each other. And so I'm going to think of a radius. What do I want that radius to be, right? So I'll make a radius of, that's not what I did over here. What did I do? Radius. It's relative to the platter size. Okay. So over here, let me back up. I'm copying another thing I did before. So over here I can say, I can make a variable, platter size. And I want that to be 40. Platter size equals 40. And so now I can actually use that variable. So I could replace that 40 with this variable and this other 40 with the same one. Platter size. Make this a little bigger. And then run that. And so the nice thing, if I do that, I've got a variable now. So I can change just this to 60, and it will actually replace both of those in there. Let me put it back to 40. So I want my platter size to be 40. But to do that, now I want to back up a second, and I want to do cylinders. So let me do that. If I do 2 slash, it's like a comment, so now that no longer will actually be created. So I want to make a cylinder. So I can make a cylinder. That'll be my rounded edge. So I'll have a cylinder, and I'll say, we got a platter height too. Platter height equals 2, which I did before. So I have a cylinder, and the cylinder, the height is the same as that platter height. And then I have, when I'm making a cylinder, I have a lower radius and an upper radius. So as an example, if I did this, I did a 10 and a 5. If I did that, we would see a little cylinder that becomes kind of conish. If I made them the same, 10 and 10, we'll see I get a cylinder like I want. Okay, so there we go. So now what I would like to do is I want to make that radius relative to my platter size, because as I get a bigger and bigger platter, I probably want a bigger and bigger radius. So what I came up with before is to make a variable. I made a variable called radius, but I made that variable related to my platter size. So I can do platter size divided by, here we go, I did it divided by 8. And then from here I can go radius, and run it. Boom. And so there is my rounded edge. Okay, so, but now I need to make 4 of those. And I need to put them in different spots. And so if I come here and I make another cylinder that is the same exact cylinder, if I do this, you won't notice anything because it actually draws the cylinder in the same exact spot. So that's not helping me. Now in OpenScad, there's a bunch of transformation tools that allow you to move and rotate and do things like that. I'm going to keep it simple. We're just going to use the one called translate. And all translate does is when you put translate before you draw something, it kind of changes where you're starting to draw. So I'll come in here, and on that first one, I'll do a little translate because I don't actually want even that first one where it's at. Okay. And I'll come up here and I'll do a translate. And then we have, in here we can do an X, a Y, and a Z. I'm just sticking those for a second here. That, curly brackets, and then like an end curly brackets, and then everything inside of those curly brackets will now be drawn in that new position. So I could say, let me comment this one out. So here I could say, okay, in my X, I want to go over 10, in the Y, keep it 0, and Z, go up 10. So if I run that as a test, you'll see this moved. So it moved along the X-axis, so it moved over. It also moved along the Z-axis, and so it was drawn in a new place. Now in my case, I don't want to move in the Z-axis, but I do want to, I don't want to move in the X, but I do want to move in the Y. And I want to move with the Y the exact radius of this platter. So I can reuse that variable radius right here. And if I run this, boom, you should see now it is drawn right there. Oh, you know, I might want to move it some more. So it got moved there, but if I want it to be right in that corner, I would also have to move it over radius, there. Radius X. So move it radius X and radius Y, and boom. So there we go. So now I got my little corner, right? So now I want to draw 4 more, but I need to translate those to the right location. But before I do, let me come down and draw my cubes. And what I want to draw, well, okay, no. Let me do the cylinders because otherwise it might be a little confusing. So I have a cylinder here, and another cylinder that's translated a little bit more over. So I want that one to be, I want it to be in such a place that the very edge of that cylinder is going to be 40 over from the edge over here. So I'll come here and I'll do another translate. I'll put this cylinder in there. But now on the x-axis, we want to actually go platter size over. But then we actually need to pull it back the radius, because where it'll start drawing the platter. So to pull it back the radius, so we say platter size minus radius, and then draw that, and I believe that should stick it right there. Perfect. So the next thing to do is draw 2 more, but just up here, similar locations. So I can actually copy both of these, paste them down here, And so the amount they are over in the x is exactly what I want, but the amount in the y is not what I want. So in this case, since I'm drawing it above, I will do, I think I just need to do platter size minus radius, and platter size minus radius. Run that. Boom, there we go. So I have them all positioned where I want. Now I need to draw two cubes. So the first cube will go here, 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 and here, and it'll cover up that spot. The next cube will go here, 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 here. And so I have these two cubes that are kind of crossing each other, but then the cylinders will make up, will make the rounded edge, basically. So I can come down here, and we can draw a cube. So if I just let this go, platter size on both, we'll see it just kind of covers everything up. That's not what I want. So this needs to be, for the first one, the x version, it needs to be platter size minus 2 radius. So platter size minus 2 times radius. And so that'll work, but I need to translate it and move it over a little bit. So I can grab one of these translates and paste it and close it. In this case, I just want to move it in the x-axis, just the radius, and everywhere else, just a 0, I think. There we go. So now you probably see what I was trying to say. It's hard to show, hard to explain. It's easy to show, right? So here that is, they perfectly match up, right? But now I need to draw the other cube that way, right? So I can just copy that. And so for my radius, so for this one, I need to be over 0. I need to be up radius in the y. But then my cube size, I need to kind of reverse that. So it needs to be platter size in the x, and platter size minus 2 times radius in the y. So run that. Boom. Now I've got that guy. And the nice thing, because I have these as variables everywhere, I can come up here, and rather than being 40, if I change my mind, I want it to be 80, change to 80, run it, and it works just fine. And I did that radius relative to the platter size, so I can just keep kind of going up, and it just works. And if I change my mind, I want to make this 100, and I want the height to be 20. I just change 2 variables, and I'm done. Oh, oops, I messed something up, didn't I? Platter height. Okay, I'm applying the platter height to the cylinders, but obviously not. Oops. Okay, so the cube is up there. I messed up my code. See, that's a perfect example. So rather than put in a variable here, I put the number 2. It should be platter height. So now I run that. I get exactly what I was, so I only have to change 2 places to get what I want. Put it back to 10 and put it back to 40. There we go. So this is what I want for my platter. Okay, so next I'm going to figure out the fonts. Okay, for fonts. So if you look here in the 2D section on the cheat sheet, you should see here there's text. So you can actually put text, but it's only 2D, so that's not going to work very well for us. But it turns out you can draw a 2D, and then later on they have another tool here called linear extrude. So you can draw a 2D dimension and tell it to extrude it up. So that's what we're going to use. Now the nice thing about this compared to Tinkercad, which I think is a great way to go, probably the way to go, now that I'm on my machine, I can use any font available to my machine to draw. Let's go down here to the bottom, and I'll just make a comment here, writing section. So I can come down here, and I can use their text. So I can say text, I'll just put a number here, number 5, so it's going to draw the number 5. And then I can say size, how big do you want it? I'll just make it 30 for now. And then I can say, okay, what do I want? There's some other features in here. Font. I actually have to tell what font I want it to use. And if you're not sure what font you have, you can come up here to the Help section of OpenSCAD, click on that, and go down to Font List. Click on that, and here's all the fonts that are currently on your system. Now, one I used for this that I like so far, let's see what I have. I used, looking at my cheat sheet over here, Arial Black? Does that seem right? I guess. Arial Black. So there's Arial Black. So I'll come down here and type in Arial Black. And we'll see how well that does. And then we have some alignments we can do, which I had to do it because I want this thing to line up correctly on this. So I can say, whatever you're going to draw, I'm going to say H align, which I think is horizontal align. Make that center. And V align, which is vertical align. Center that too. And then down here, I can actually override the FN, which I guess, well, I did before, but maybe I won't now. Nah, we'll leave it like that. So it'll be 12, so it might be a little blocky. That's okay, because we'll update that for our last render. Otherwise, I can go in here and do FN equals 50. And in most of these, I think in all the methods, you can actually override the FN. And you may want to for different reasons, where you have the default one that is used for everything, and then individually you could override it if you need to. But in this case, I'll try not to this time. And I'll run it. Oh. I drew a 2D object, but it's like you can't see it because it's not three-dimensional, right? I might be able to see it if it wasn't right there. In fact, let's try that. We need to translate this anyway at some point. So I'll translate it. Just for kicks, I'll move it 50 over 0, 0. I don't know if you can actually see it because it's two-dimensional. I haven't tried. No, it's not showing up, right? Because it's 2D. There's nothing to render. But so we're going to use this thing called linear extrude. So we can come down here and we can do a linear extrude. And we can tell it how high we want this to be. So we'll come down here and we'll say 4 for now, just to get started. And then I can do curly brackets, which means everything in here that's a 2D object will be extruded. Hit that. And see, I moved that over 100, so there it is way over here. We'll move it back just 10 just to show it. And so there it is. So I can put a number in here. I could even, say hello, and it will render it. And now the cool thing is you're using your fonts. So you can probably find some better, more friendly fonts than what you can find on Tinkercad, which is, kind of cool. So let me go back and put a 5 here. And let me start to clean this up and try to code it a little better. So what I can do is this linear extrude is the letter height. So let me make a variable called letter height. And we'll copy that. I'll go to the top. It's a little more convenient to have everything at the top, right? And so I'll make the letter height, and we'll make it 2. And I'll come down here, and I'll start to work on the translate. So let's make this 0, 0, 0 for the moment. But then where we really want to draw the lettering, since I just gave it a height of 2, is we want to start drawing the lettering on top of our platter. So we can use our platter height right there as our start of our Z in the translate. So I'll say Z is the platter height. So now if I run that, still not lined up, but you should see now it's starting to draw right at the level of the platter. And so that kind of works for me. Okay, but now how do we align it? And we want to align it. We want to change the size. Let's change the size first, because we want that size of that font to be relative to the size of our platter as we change it. So rather than being 30, I can come up here and I can say, okay, here's a letter height, and we can say a letter size, or font size. How about font size? Font size. And we want that to be relative. So I can say, here's what I used over here, 0.8 times platter size. And that's what worked for me recently. Now we'll copy that font size and we'll paste it down here. So now if I run it, it might change the size a little bit, but the nice thing is, if all of a sudden now I want to change my platter size, that font size should adjust. See, and it did. So good. Bring that back down to 40. But now I need to organize it. So I need to translate in the right place. So what I came up with for my translation for the X and Y was I can come up here and do the platter size divided by 2 minus the radius. I know I fiddle with that a little bit because it's centered and that kind of worked for what I was doing. And so, and then for, oops, not that one. And then for the Y, did I do the same thing? No, I did platter size divided by 2. Okay, that worked. And so now, let's see if it centered it very well. Oh, not too shabby, but it's a little bit over. So let me see, center size minus radius. Okay, my X is not where it should be. Well, this is a little different design than what I did. So, I don't think I need that radius. Let me fix that. There we go. So that's pretty well centered for what I need. There we go. So now let me change the fonts. Let me change the, rather than a 5, let's put a 3 in there just to see if it still looks pretty well. Cool, that's centered enough. Looks good to me. So, there you go. Let's see, what else can we do? We have, what other variables do we need? Platter size, platter height, string. That's an important thing. So rather than put the lettering down there, I can stick a variable up here. So I'll put 3 just up here. And so now we'll use that string variable, and we'll put that here. So now, and font. I can put that font up here too. So I did a font equals Arial Black, and then replace this with font. Font equals font? Yeah, font equals font. Sounds a little silly, right? Font equals font. So now everything's a variable, and all the variables are up in this section. Makes my life easy to change them. Let's render that. Oh, need a semicolon. There we go. So now if I want to change the font to something else, I can change that right there. If I want to change the platter height, I change it there. If I want to change what's actually going to be printed out, if I want to do a plus sign, change it right there. And so there you go. So there is the code. It's easy peasy to fiddle with. And so now let me take this and let's do an 8. Render it. Save it as an STL file. I'll put it on cancel. I'll put it on the desktop, and I'll call it 8. Then I can come over and go to my desktop, go to Prusa Control, delete that little ball there, and drop in 8. Boom. And there we go. I got a little platter, all made in OpenScad. And then over here, I can, of course, just do a sparse 0.2 millimeters, generate this. And then I can do what I did last time, go up to 2 millimeters, 2.1, 2.2, and hit the plus button, which will tell it that I can switch out filament. So if I want to have, like I did last time, have a different color, so I can make this black and make the 8 red, which I thought was a pretty cool idea. But there you go. That's how you do an OpenScad. Now, the last thing I want to show is all the Unicode characters you can do that I couldn't quite do in Tinkercad just because they didn't have them all available in the font. Okay, on to some Unicode. Now, real briefly, if you're not familiar with Unicode, all it is a bunch of characters. So currently, pretty much everything we do in text nowadays is pretty much Unicode. And so in Unicode, they have all the characters for pretty much all the languages. So they actually have Egyptian hieroglyphs in there. They have kanji, Japanese kanji, all the Chinese letters, all the hieroglyphs and not hieroglyphs, glyphs, and mathematical symbols. Now, just because it's available in Unicode does not mean that your particular font took the time to actually define every single image or glyph for every single character. So you have to kind of fiddle with that. So but let's start to fiddle. So here I am on Wikipedia looking at some mathematical operators that are in Unicode. So I can come down here and find something like there you go, greater than or equals to sign right there, right? And so I can come in here and select that and just straight up copy it. And there's a good chance it'll just paste in here just fine. So if I paste that in there, in this case, there you go, it actually shows up. And then I can render this, and hopefully it'll work, because I imagine, oh, there you go. So Arial Black happens to have that. So it shows up just fine. Another thing I can do is Unicode has a numbering system. So I can actually go \U and then go here and find the number. So here is where it shows up. So this is actually numbered 226. And you see that X there, and the X represents the line it's in. So that's 5. So this is 2265. So I'll come over here and say I can say 2265. And then run it. And I get the same exact results. But I can also come over here and say, let me find a different one. So I can say, here you go, how about an angle? 2221. So I'll say 2221 and run it. And there's a good example. The Arial Black font does not happen to have this symbol. So as a result, you get this little square, which means I don't have it. But another font I have may have it. I'm not going to go hunting and pecking right now. But it's a good thing to note. If you're trying to do some mathematical symbol and it doesn't exist in there, it might exist in a different font. So that's a cool thing. If you're using OpenSCAD, you can probably find some kind of font that will support it. Let me go down and choose something else. How about a cube root, right? So I'll copy that. I'll just straight up copy that, because that could be an interesting example. So I'll do cube root, which shows up here, but it may not show up there. We'll see. Perfect example. So whatever font's being used here has a cube root symbol. The font that's actually putting this text in OpenSCAD. But I chose Arial Black, which just does not have it. So you got to figure out what you have and what you don't have. Okay, let me find something that probably has. Where's I don't know. There's all kinds of cool symbols, right? I bet you it has that one. Square root. Should have a square root, right? So let's try square root. Boom. Has it, but it's kind of a big guy. Oh, yeah, see? Might have to adjust some of these fonts, because that one's a little big for this guy. But anyway, I just kind of want to cover that you can do Unicode in here, which you can do in Tinkercad. But in both instances, the Unicode has to be in the font you're using. In Tinkercad, you only have a choice of 3 fonts currently. I'm not sure if that's ever going to change. But on your own system, you can download all kinds of fonts, and you probably already have a lot to begin with. And so you can probably find one that's more math-friendly if you're doing some higher concepts. So if you need a cubed root, you can probably find one that has a cube root. So just kind of want to cover that. I think that's really cool. Cool. So I'm really happy for that suggestion that Oslo had to try this out in Tinkercad, because it seems like a really interesting way to go, especially if you're making a bunch of them. You can go through and just make a bunch real quickly, but just by switching a few variables out. But I do also still support the idea, if you have a younger kid, it's probably really nice to get them involved and helping out. And I think it might be better to do it in Tinkercad, or maybe if they're smart enough or older enough, OpenSCAD might be another way to get them involved. I recently did some OpenSCAD with my 10-year-old daughter. She fought it a little bit, but in the end, she got it. In fact, we're printing out a giant snowman she made right now. So it depends on your kid, depends on their age, depends on their mentality. Either way, I think it's a good idea to get them involved in the process. But this might be a good way if you're going to print a bunch for a class out. You could automate the process. So anyway, just kind of want to go over that. OpenScad, manipulatives, doing numbers. It's a really good way to go. Hey, if you liked the video, please give it a thumbs up. If you didn't, hey, give it a thumbs down. Also, if you like what we were doing here, subscribe to the channel by clicking the subscribe button. And lastly, have a piece of info to share? Just post a comment.